Alright guys, so this is Unit 2, Lesson 3, and today we're going to focus on domain range and inverse. We're going to graph and name points on the coordinate plane. We're going to represent relations as sets of ordered pairs. We're going to put them in mapping, we're going to put them on a graph, and in a table. We're going to be able to find the inverse of a relationship, and we're going to be able to find the domain and range of a relationship. Okay, so this is a coordinate plane. Hopefully you remember the coordinate plane. This is the y-axis. This is the x-axis. This is the first quadrant, second, third, and fourth. And so I'm not really going to we'll go into this a little bit when we go over class, but I want you to name the ordered pair for each point in the quadrant in which each point is located. So, for example, on this you're going to write G, and G is located at 1, 4, and it's in quadrant 1. I will tell you that I and J are on an axis. So when you write down about I and J, you're going to have to make sure you understand that they are on an axis. So you're also going to write down the points and their location of these. And we'll check this in class tomorrow. Again, I'm doing this quick because it should be a review. Graphing the points, that should also be a review. -1, 5. I'm going to place M. So on your own time tomorrow, make sure you plot H, Y, V, and K and have that ready for class tomorrow as well. We're also going to talk about how we look at a set of ordered pairs. And remember, we did this when we did functions. So when you make a table, you order the x values from least to greatest. Then you match the y values to that. When you make a mapping, you order the x values from least to greatest. You do not need to match any values because you use arrows to match the x's and the y's. So an example of that is we have a set of ordered pairs. We have 4, 2, -5, -3, 0, 2, and 4, -1. And so we are going to take that relationship, and we've already graphed it. Now let's look at it in a table. So when we have a table, we order the x values. So we have, -5 is there. I don't know why I did that. So we have -5, we have 0, and we have 4 and 4. And notice how I had to write 4 twice for the table. And then we pair the y values with it. So -5, 3, 0, 2, 4, -1, and 4, 2. Doesn't matter which order we go in there, as long as we get them all there. However, when we put them into a mapping, we go -5, 0, 4. And I only write 4 once. And then we go -3, 2, -1. And again, I'm only going to write 2 once. And then we pair them using arrows. Is this relationship a function? Just kind of reminding you from previous discussions. No, it's not. Okay. The reason why it's not is because the x doubles up. Domain and range. So remember, we talked about this before. Domain is the x values in a set, and a range is the y values. And remember, when you're doing domain and range, you want to keep them in alphabetical order. So remember, domain comes first, so it pairs with the x. Range comes second, so it pairs with the y. So the domain of the set in this ordered pair set here is -2, 5, and 6. And when we use a set, we don't use parentheses. We use that, I don't know what you call them, brackets. So we use kind of it's called set builder notation, so we put them in sets. And the range is negative 10, 7. So again, the domain pairs up with the x's, the range pairs up with the y's. So in order for you to practice this, I want you to go ahead and do this slide, and I'm going to have the answers for you. I want you to tell me what the domain is, what the range is, and then I want you to put these sets in a mapping and a table. So go ahead and pause the video, do the domain and range, and then do the mapping and the table. Okay, so hopefully you were able to do that. The domain was negative 7, negative 2, 7. The range was negative 5, 2, 6, and 9. I expressed them as a mapping and as a table. Obviously, these could have been in any order as long as they match up. And these two could have been in any order as long as you had them paired up with the negative 2. Alright. The inverse of a function. All you have to do to find the inverse is you switch the input and the output. So in other words, you're going to flip the x and the y. So if this is my original function, then the inverse is 5, 4. Notice I flipped 4, 5. Negative 1, 7. And 2, 9. So if we were going to do this one, we would write the relationship, negative 3, 6. 2, negative 4, and 5, 7. And then in order to show the inverse, we would just flip. 6, negative 3, negative 4, 2, and 7, 5. Pretty easy. And hopefully you guys will find it easy when we practice in class. The last thing that we can do is we can substitute. So if I give you a domain of negative 2, negative 1, 2, 3, and 5, and an equation, can you find the range? Well, sure. Because if I give you negative 2, you plug it in, and you end up getting 8. We won't worry about this. I mean, obviously, you know how to write an ordered pair. If I give you negative 1, you plug it in, and you get 6. If I give you 2, you plug it in, and you get 0. If I give you 3, you plug it in, and you get negative 2. And finally, if I give you 5, you plug it in, and you get negative 6. And so the answer that you're looking for, if you're looking for the range, you would list this whole set of numbers. So if I said to give the range, your answer would be 8, 6, no, we're going to back up. Negative 6, negative 2, 0, 6, 8. If I told you to solve it, that's when all the ordered pairs come into play. But more than likely, what you're going to be asked to do is to name the range given the domain. And that's what I've got you doing here. So we're going to finish this video with, I've given you two equations, and I've given you the domain. All I'm asking you to do is substitute for x and give me the values of the range. So we will check these tomorrow in class as part of your classwork. Thanks for watching this video, and when you're done with this, we're going to have a quick video on patterns that you need to watch to go with this.